Welcome to the Real Python Podcast. This is episode 160. What are the unique challenges of a large Python code base? What techniques can you implement to simplify the management of a big project? This week on the show, Christopher Trudeau is here, bringing another batch of PyCoders Weekly articles and projects. We discuss a recent thread on Hacker News about working with a large Python code base. Christopher advises configuring tests and using tools to keep your code consistent across an organization. He also answers several questions about code complexity, typing, and leveraging third-party libraries. We cover several other articles and projects from the Python community, including news from the Python Language Summit, using Kivy for GUI development, understanding the power of bit manipulation, removing unused import statements in your code, and adding reminders about links from a podcast using a Python-based iOS project. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back to the show.
Hey there.
So we were going to bypass the news segment, but it seems like some of the topics that you're putting together for this first grouping are kind of newsworthy.
Yeah, sure. Why not?
Okay.
News or not news, however you want to do it. So,
Right.
End of the PyCon conference that just sort of closed up a few weeks back. They have the Python Language Summit. This is an event for developers who are involved in writing Python implementations. So CPython, PyPy, all that kind of good stuff. And it's a full day event with multiple conversations about like the future of the language. And sometimes they talk about upcoming PEPs and that kind of good thing. And so a bunch of blog posts and articles have been popping up that are kind of little snippets that things they talked about.
Yeah.
We've talked on some of these topics before, so I'm just going to sort of quickly summarize. And if you want, you can sort of dig more deeply into other things.
Okay.
The first one was a progress report on PEP 594. And for those of you who don't have the PEP numbers memorized, PEP 594 is the dead batteries PEP. That's they marked a bunch of standard libraries for removal in 3.12 and 3.13. 19 modules were deprecated in 3.11, and now they've got inside of the 3.13 branch that removal has happened.
Yeah.
Of course, 3.13 is still a ways off. We don't even have 3.12 yet, but this is a work in progress. There's a good summary post on the Python discussion board from Victor Steiner, who's the coder who's actually doing the work. Talks about what got removed and what your choices are if you're using one of those things and you still need it, what all that kind of looks like. The next two bits are blog posts by Alex Waygood, who writes on the Python Software Foundation blog. The first blog entry is around the continuing conversations about the GIL. There's a lot of ongoing work connected to the global interpreter lock, much of which we've talked about before.
Yep.
One project is PEP 703, which proposes to make the GIL optional in CPython, and this is also slotted for Python 3.13. At the summit, Sam Gross, who's the author of the PEP, gave an update on the progress and the impact of the change. At the moment, the no-GIL implementation, which is the branch he's working on playing with this stuff, is about 6% slower on a single-threaded core, which isn't too bad a hit considering the speed up that you'd get for multi-threaded code.
Okay.
Sam thinks they may even be able to get even lower than that. And so there were some conversations around the implementation, its impact, questions, that kind of stuff. And especially, evidently, this makes debugging a little more complicated somehow. I wasn't clear how to me. I'm sure you can dig into stuff in the PEPs to find that out a little more if you're curious. And we'll link to the blog post and the PEP. I also came across today the discussion on the PEP inside of the Python discussion thread has resurfaced, and there seems to be a bit of a tense conversation going on. So it'll be interesting to see what comes out of all this. And we'll link to that as well and see what gets settled out of that. The other blog post from the summit that I want to talk about is titled, "What is the standard library for?" And this kind of loops back to where I started here with PEP 594. So there's been a bunch of conversations in the last few years about what should be removed from the standard library. And at the summit, they talked about creating some guidelines for when to add something and when to remove something from the standard library. It's kind of a meta conversation about having some rules about how to have future conversations, but that could actually make it simpler to make these kinds of decisions in the future. So there's lots going on at the language level, and I love that our community is so open about this and it's getting talked about. And sometimes you don't always want to know how the sausage gets made, but it's definitely interesting.
Yeah, I mean, we've talked about it, I don't know, over the last several weeks, kind of starting just before PyCon, about these different parts of the overarching Python organization, having blogs, posting about what's going on. We talked about a lot of the stuff happening with PyPI 2 weeks ago. So the transparency is good, but sometimes, there's some interesting stuff when you turn on the lights, and, so it'll be interesting to keep following. And at least this is not all happening behind closed doors completely. They're at least, sharing after they have this summit and stuff, what's happening. So that's good. So my first one is a real Python tutorial, and it's by our friend Leodanis Pozo Ramos. This one is related to a lot of the concepts that we've been covering, over the last several months, talking about object-oriented programming, talking about metaprogramming, and some of these other kinds of things that are involved in creation of objects and in that vein. And it's titled Python's Dunder Call Method, Creating Callable Instances. So functions, classes, methods, they're all common examples of things that are callable inside of Python. To call something, you type the name of the function, then have a pair of parentheses after it, and that's calling it. But you can also create custom classes that can produce callable instances, where you can actually just type the name of the object, the instance that you just created, and put parentheses with it. So this talks about how that works. It talks about how instances with a call method can act like an actual function. And it's a really neat way to add functionality, pun intended, to your objects. The tutorial goes into what are the different types of existing callable objects. There's a pretty thorough list of them in there. We've already talked about the built-in functions and classes, but user-defined functions, things that you create with def, lambdas, the constructors of your custom classes, instances, classes, static methods, but also things like generators or closures. And so this is really trying to define how to use this dunder call method. It takes you through more of what kind of a thorough explanation of the differences between the dunder init and then dunder call, with code examples using the callable instances to sort of solve some real world problems. And along the way, you create several callable instances by adding the dunder call method to your class. So you also get to explore, if you haven't done much of this, this is definitely kind of in the intermediate camp. Again, something that you would get into after you've played with object-oriented programming. And you explore by using the dir command, which returns the list of the current scope. If you just type in dir and parentheses, call it. If you add an argument, as in you add the name of a function or a class or something like that, it will attempt to return a list of the valid attributes for that object. So like you could say dir all, and that would show the built-in function all or absolute or something like that. And it would show inside that list of things that are in there, methods that are in there, you'd see dunder call as one of them. It has several examples of you creating versions of this and practicing with it. He has an example where you're building a factory as you create the class. In this case, he's using a pretty common example of a power factory. So when you initialize under the dunder init, you're setting like an exponent value. But when you define the dunder call method, you can have a base to it. So the base, again, in this case, it's an exponent, so it's raising to the power of. And it's a pretty cool example for trying to show off the idea of this. He shows a couple other examples of like instances of classes that can retain state between calls, how to cache values from previous computations. And then in something like a GUI, which I'll talk a little bit more about later, sometimes having an instance of something and having it callable makes it a little less confusing, or maybe a more convenient or clearer way of setting up an API for something. So he talks about creating an instance of window, and instead of like having to have like a show method that then shows the window, it could just be call window and have that calling it right after that, having it show it. So it can make it a little more convenient, a little clearer. And then a couple more advanced techniques he gets into at the end, because it's a late honest article. He gets into writing class decorators and then implementing the strategy design pattern. It's a nice article. I think the best thing you'll get out of it is if you have kind of an unclear idea of how an instance can just by itself be called, or what's the difference of when I initialize something as versus I want to try this thing out with these special method of dunder call. I found it really useful, got me in a little deeper into the idea, and there's a couple useful things. Like I really like that idea of making an API a little bit cleaner by just simplifying how you could call a standard method by calling the object itself.
Yeah, there's a whole bunch of things in Python that look like functions that aren't.
Right.
A bunch of standard library things that if you look at it and go, oh, that's a function. Actually, nope, it's a class, and it's a class that's implemented the callable. And it's an interesting feature of the language that you, as the user, you don't care. You just call it.
Right.
This also ties back to some of the metaclass stuff we talked about a couple weeks ago, because that's the same mechanism that's used there.
Yeah, it's all kind of in the same vein. Cool. So what's your next one?
So this is an article from Anurag Verma, and it's called The Power of Bit Manipulation. Kind of made me feel all old school. You see, back in the old days, we had to carve the bits directly into the hard drive with a chisel. I'm not
you weren't even doing paper and...
I'm not actually quite that old, but I did have a boss who told a story about fixing a magnetic drum, which is a precursor to hard drives, with a screwdriver, because the spots on them, the bits were big enough that you could actually poke it and change the magnetic. I'm not sure whether the story is hyperbole, but that doesn't stop me from enjoying it, because it feels just true enough to be interesting. But anyway.
Yeah, totally.
So in languages like C that are a little closer to the hardware, you often need to be concerned about the bits that make up a byte. And back when memory was more precious, you sometimes would use bits to store things as they're 8 times more compact than a byte, for example. You don't come across this in Python anywhere near as often, but there are situations where bit manipulation is still useful. And if you're new to this space and Python's your first language, you haven't run into this in other places, this article covers a lot of the details really, really well. So Anurag starts out by teaching you the fundamental bit operators, which are AND, OR, XOR, NOT, and shifting. And, OR, and NOT are familiar, hopefully, because they are similar to what we use on Booleans. And as a bit is just on or off, that kind of maps to Booleans nicely. So that sort of makes sense. XOR and shifting might be new to you if you haven't done bit math before. XOR is exclusive OR, and that's similar to ORing, except if both bits are on, the result is false.
Okay.
So that's the exclusive part, right? So one is on or the other is on, but not both. And then shifting is the idea of moving one or more bits left or right within the byte. And that might seem strange at first, but when you think about the fact that bits represent powers of 2 in an integer, shifting them is the equivalent of multiplying or dividing by 2. Think of like adding or removing a decimal place in base 10 math. So that's the general idea. And with the fundamental operations explained, the article goes on to talk about bit masking. Bitmask is a series of bits inside of a byte that's applied to another byte to perform an operation. And a simple and very common example of this is trying to determine if, say, the 5th byte is on or not. And by combining your byte with a bit mask, you can arrive at a true or false conclusion in regards to the 5th bit. And you can build these kinds of bit masks using shifting, and you apply them with AND, so that all moves back to the fundamentals in the article. So with bit masks, you can figure out, like I said, whether things are on or off, but you can also figure out like setting specific bits. And this can get interesting if you're doing stuff like graphics or things directly to the hardware, because changing the position of those bits affects what you're doing. After bit masking, the article covers counting bits, rotating bits, reversing bits, swapping bits, multiplication, division stuff I was just talking about, and then goes on to show a series of algorithms that are commonly used at the bit level, like bit mapping. So if you're heading into the graphics space or the gaming space where these kinds of tools are more common,
Yeah.
Or if you want to play with deeper networking stuff, packet headers often have bit flags in them. So this is a good skill to add to your tool chest if you like. And all in all, it's a good article with a nice little intro to the topic, and I'd recommend it.
I remember you did a course on binary and bytes and bitwise operators, and it sounds like there's a lot of similar stuff there, but in this case, it would be a video course that you did.
Yes. Yeah, there's a fair amount of similarity. I think I cover most of what's in the article. He covers a couple of algorithms that I don't, and I cover a couple of things like how floating point works.
Yeah.
That he doesn't. So yeah, a bit of a mix and match. But yeah, if you want the video version, that is available. We'll have to remember to link to it.
Yeah. I'll include a link for it. Awesome. My next one is about Kivy. It's by Francis Ali. It's on the website pythonguis.com, which is kind of an interesting site. It's sort of an overview of all these different GUI frameworks, and we've talked about a lot of them on here. And I think we might have talked about Kivy before, but I'll mention that. What's nice about this tutorial is it's really an overview and hey, get started, kind of play with it. I mean, that's literally its title, Getting Started with Kivy for GUI Development. And it has lots of little first steps to kind of get you going. It takes you through writing a hello world and then really lets you kind of play and explore a little bit with some of the widgets and layout tools you do in Kivy. I didn't mention it yet. Kivy is an open source library that is designed in a little bit different way from other graphical user interface libraries. It's designed to be very cross-platform all the way to mobile devices. And so you can create, not only for Windows, Mac, Linux, but also for iOS and Android. Even supports like things like multi-touch and things like that. So after the hello world and kind of exploring a handful of some of the widgets and layout tools, they kind of give you just kind of a listing of some of the things that are in there, typical GUI stuff like, hey, you have text inputs, you have labels, buttons, checkboxes, and a couple unique things like progress bars and drop-down menus and images and things like that. It has a lot of different layouts, which is a unique thing with Kivy. It has typical stuff like grids and page layouts, but there's a thing called like a scatter layout and a stack layout that feel slightly unique. And then there's examples that you get to practice a little bit with it, trying out button layouts. And then something I hadn't seen before, which is kind of playing around inside their canvas property, where you're going down to the level of actually like drawing lines and rectangles and ellipses and stuff like that, and how to do color inside there. There's a few unique things to the library. It has its own language, sort of a styling way that you can kind of set up, I don't know, sort of prototypes, things that you can reuse inside there. And it uses its own KV language inside there. And so you would create a file and uses angle brackets and then sort of like a bit of a dictionary style to name things that you're creating in there. So you could be like angle brackets, custom label, and then text, hey, this is going to say, hello world or whatever. And those get saved in a .kv file, which makes it in some ways reusable and maybe across multiple projects or something like that. It has a few other features they mentioned kind of near the end of it, a builder class and something called automatic widget loading. And if you're looking for another take on a tutorial like this, RealPython has one that was actually kind of a little more geared toward, okay, let's create an app. And in that one, you create a calculator app. That tutorial is called Build a Mobile Application with the Kivy Python framework. So you design the basic logic of a calculator, lay out all the buttons and so forth. And then it talks about some of the steps involved in getting it to a Mac then and getting it to Windows and sort of the distribution parts. And then the mobile stuff is always interesting and of all things, quite the moving target because of just how the development changes from literally every year for things like iOS or Android. So, but it does give you the resources and the additional tools that you would need to get there. So if you're interested in playing around in the GUI world, Kivy is one of the powerful tools that's out there, and this is a good getting started. And then here's some more resources for you to play with.
Have you written much with it?
I've done technical reviews of the Kivy, not the article, but the video course,
right,
which I might feature this week, which was Darren's. And I liked working in it. It's kind of a nice Like, I like that reusability part of it. That's kind of interesting. And it looks pretty nice. The trick is, with all these GUI things, that does it look native on the particular platform that you're in, or how foreign does it look? It looks fairly modern.
That's the usual complaint. I did some prototyping with it for mobile work 5 or 6 years ago.
Okay.
And we had no intent of using it. It was really just to get some screen flows and be able to talk to VCs and that kind of thing. So as a quick and dirty prototyping mechanism, it worked relatively well.
Right.
At the time, I think we had to use a jailbroken phone in order to get the Python stuff onto it, and those complications, some of that may have become easier. It was an interesting little experience, but the one thing that kind of stuck in my head was nothing we did looked like Android. It just looked like whatever we did.
Yeah.
It looked like Kivy wherever you are. So, yeah.
Right. A lot of these frameworks are that way, Tkinter and some other ones. I think the one thing that might be trying to cross that is Beware. Yeah. He's trying really hard to use the native stuff. So I'm intrigued to see developments with that, and especially now that Russell has some funding, to be a little more full-time with it. So that project's moving much faster. So, and it's definitely geared toward, hey, this is the first thing we want to do, is make it distributed everywhere. This week, I want to shine a spotlight on another Real Python video course. It's about a topic we covered this week and is another resource for getting you up to speed building GUI interfaces for your Python applications. The course is titled Build Cross-Platform GUI Apps with Kivy. It's based on a Real Python tutorial by previous guest Mike Driscoll, and the video course is presented by instructor Darren Jones. He shows you how to work with Kivy widgets, lay out the user interface, add events, and use the KV language, and also how to create a calculator application, then package your application for Windows, Linux, and Mac OS, and then how to research the tools to package for iOS and Android. This is an intermediate video course. You'll need to be familiar with object-oriented programming, but we've got you covered here at RealPython with multiple courses to get you up to speed. If you're interested in building cross-platform GUI interfaces, this is a worthy investment of your time. And like all the video courses on RealPython, the course is broken into easily consumable sections. Plus, you get additional resources and code examples for the techniques shown. All of our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So we have a discussion this week. You found a topic that we were going to dig into. It's a Hacker News thread, right?
Yes. So it's called How Do You Deal with a Large Python Code Base? Gentleman asking the question is working on a code base with, he says, somewhere between 10 and 100,000 lines of code. That's a big range.
Yeah. There's like 90,000 in that range.
Yes. Sort of just looking for tips and hints as to, how to deal with that and what it looks like. It's interesting. I find, to me, with this kind of thing, that most of the advice is almost language independent.
Yeah.
And, one of the things I like to try and sort of distinguish between is, the larger the code base, the two things you need to start thinking about is, how do I maintain the quality? And something that's kind of connected to that is a psychology thing.
Okay.
So, and what I mean by that is, at my peak, when I was a very junior developer and I didn't have to attend any meetings and I was heads down and whatever, I was producing about 10,000 lines of code a month. And so what that means is when you start getting into large, depending on your definition of large, that's 5 or 6 months worth of work or a year's worth of work. And you start forgetting what the pieces are. In all likelihood in the industry, that's not how 100,000 lines get produced. How 100,000 lines gets produced is you've got 9 or 10 or whatever people touching it. And the people who are touching it over time aren't necessarily the same people because people come and go.
Right.
And so the psychology of it starts to become not just what is the current quality, but how do we ensure that the future quality is up to snuff? And one of those things that most developers find a very difficult concept to deal with is, on average, you're the average programmer. which means on average, half the team's going to be better than you and half the team's going to be worse than you. And so we start talking about a lot of things. So when people in Python start talking all about like typing and all the rest of it, usually what they're really talking about is, I don't trust the other people on the team to write good code unless we enforce certain rules. And so larger code bases start to become about, what rules are we going to have, and how do we make sure, preferably in as automated a fashion as possible, do we stay with those rules in order to maintain the code quality?
That makes sense to me, yeah.
And there's other aspects of it which unfortunately are very hard to enforce at that level, which is things like architectural rules, like we're going to stay within our box and this thing is not going to call that thing. That kind of code understanding knowledge tends to be a little harder. And so one of the things I like to sort of deal with when I'm working with teams around these topics is, I want to try and get like code knowledge, linting, black, whatever those kinds of things are, regimented on the teams. We're not going to argue about whether it's a single quote or a double quote. I hate the fact that it's a double quote in black. I don't know why. It bothers me. But it's easier to just say, okay, we'll use black and we're not going to argue about it.
Right. Yeah, what kind of percentage of the arguments does that get off the table?
A lot of them. You hear jokes about, tabs versus spaces and things like that in other programming languages. And what, not only do you get like the philosophical argument about it, one of the challenges with that is if, it doesn't happen as often in Python because the spaces are important. So we've all become very attentive about how it works. But in a language like Java where it isn't, I can set my editor up so that it uses tabs. You set yours up for spaces. I read your file in, it converts it automatically, which means when I stick it in the repo sees that as every single line in the file has changed, which is bad,
right?
Because now I can't tell what I touched and what I didn't touch because the editors touched everything, right? So
it's all red lines.
Yeah. So there's a consistency thing there that can be really, really helpful. So having these tools in place means you're not having those fights, and you can start having the conversation about, is this the right architecture? Should we concentrate on speeding this chunk up? And oftentimes by standardizing something, I make the joke about black. I think it's like all good compromises. I don't think anyone's happy with it, right? But by standardizing on something like that, we don't have to have the argument about it, and right. And so it just alleviates it, and you set what those rules are. And then the other aspect of it, I think, is the whole real estate adage of location, location, location. Well, the programming equivalent is testing, testing, testing. And the larger the code base, like if you're learning a large code base, having automated tests helps you learn it. If you don't have a lot of tests, then you have to figure out how to start putting them in. And one of the things that I find is kind of subtle is having a good set of tests that gives you good coverage across the board reduces the risk of refactoring, which means when you're dealing with things like technical debt, or you want to try to put in a performance improvement or something like that, the long-term productivity of the team goes up if you've got these tests in place, because they've got a safety net, right? You're not always doing the high wire act of, can I touch this? Should I touch this? Because you can touch it and then run the test and go, did I break it?
Yeah.
And so testing is important no matter how big the code is, but the larger the system, the harder it is for you to keep all of it in your head at any given time, which means you might not understand the consequences of the thing you're changing. Oh, this is a tiny little thing. It'll do nothing. And off it goes. I ran into this to some code I wrote the other day. I touched something and I'm like, oh, that'll make it easier and it'll make it faster. And I had the tests that were around it and they passed. And I'm like, that's fantastic. And then the other tests started failing. I'm like, oh, there was an assumption. There was a dependency there. Oh, crap. Right. So you have to go in and touch the other code, right? So this is the kind of stuff that the testing catches. And particularly because Python is dynamically typed, this becomes that much more important, because if you're not using typing, or you're not using typing to its full extent, then you need the testing to be able to help sort of catch this stuff.
Yeah. That makes me think about a couple of quick things. Like, one is, we've talked before, or at least I've had a couple of people on shows and talking about this idea of like really large functions and things like that, and the idea of like refactoring the code and so forth.
Yep.
Does adding the tests as you go, or even after the fact, tend to keep those sections not necessarily smaller, but like at least organized under, like a specific thing that you can then test for. Like, does that help, like, kind of like avoid this, thing that should be a single function doing a single function?
Yeah, in theory, test-driven development is supposed to address that, and that's the idea of writing the test first. And the reason is because the longer the function, more likely the more things it does.
Right.
And if you have to write the tests first, that means you're going to have to write a lot of tests for it. And so, having to think of, okay, I need it to do these three things. That means I'm going to have to write these three tests. It does seem to make it. I think there's a psychological aspect of I will keep it smaller so that the test that goes with it is smaller.
Okay.
So it can be helpful. And I would flip that on its head as well, right? So like if you're inheriting a large code base that has a lot of that stuff in it, the first thing you do is write tests for it. And you write the automated test for that function and you get it working. And then once you've got that, then you can go back in and go, okay, I'm going to refactor this. Because then you're not accidentally introducing a regressive bug, and you figure out whether or not you're actually doing the thing that you're doing, right?
So one of the things that seemed to be, I don't want to call it a complaint, but some of the things he was questioning in his initial post there was like, to me, does the dynamic nature of Python make it harder or, easier for a larger code base? And I don't necessarily think that. It definitely depends on your approach of how you use it.
And this comes back to the typing conversation, and we've sort of had it a bunch of times. My personal experience, and this is gonna piss a bunch of people off, but my personal experience has been the number of bugs that the typing catches doesn't make that much of a difference.
Okay.
But that might be because I'm relatively rigorous about it. I don't know. And again, this comes back to the psychology of the team, right? So if you've got a really strong team and they are disciplined about some of these kinds of things, it may not make that much of a difference. If you've got new people who aren't as disciplined, it might be easier to accidentally introduce the kinds of problems that type checking might fix.
All right.
One of the things that, it's a tool like any other. And so if you're finding that you're writing like 3 lines of indented code to define the type of your function, you might be an ace at typing, but you may also have designed the function badly, right? So like if you're finding, I need a union of this and that, then there's a chance that your function's probably too complicated. So if you use that as a signal, then, and you back off and go, maybe there's a different way of approaching this so that my type information isn't so complicated, then yeah, that's pushing you in what I would say is the right direction.
Yeah.
If you just go through and go, this function can take 6 different kinds of objects and there's 12 different use cases, and I'm going to write this horribly complicated thing that almost causes my pie to fall over, well, then typing isn't going to fix your problem, right? So,
right. Yeah, that makes sense.
It's a tool.
I wonder about also in the initial question, he mentions like some specific tooling that are from data science libraries. He mentions SciPy. And I wonder sometimes about a different form of inheritance of like problems, like in the sense that you've decided to leverage the functionality of this library. It's coming from a different organization, and potentially you might be using, several libraries, and they're all from different organizations, and they might have different approaches to development and management of their own large projects. And now you're introducing them to your code bases as opposed to like starting with maybe a singular framework or whatever, or developing it, upward from nothing. Do you think that might be something that can cause problems in these larger, code bases?
I would flip it around the other way, right?
Okay.
The less you have to think about, the more you're depending on. And obviously, there's a base level of quality that if you're pulling random stuff from the internet and the library is badly written, you're going to have issues. But particularly for things like what he's talking about here with the SciPy and those, these are well understood, stabilized libraries. Why would you try to write the equivalent of that? And what makes you think you're going to do a better job than what they did, right?
No, I'm just thinking about like the implementing it, like if you're using it with it, like, and if you have multiple projects that are like that, is it possible that stylistically that it becomes problematic management, with the
I'm
code
not.
that you're adding to it.
Yeah, I think there's an overhead because obviously you have to understand how that library works, and there may be edge cases where it doesn't have the thing you want, and you're having to shave the sides off your square peg a little bit to fit it into the round hole.
Yeah.
And there are going to be specific examples that are counter to what I'm about to say, but generally you're almost always better off using somebody else's code, entering it at the API level because they've done the work and hopefully they've written the tests that go with it. And,
Okay.
one of the reasons Python is so much more productive than a lot of other programming languages from a speed of the developer's perspective is because we can drop these libraries in and use them without any, right? Like
Sure.
stuff that I used to have to download in C or C++ as third-party libraries are built into Python. So the third-party libraries in Python are just that level even higher, right? So the more you can depend on that stuff, the better as far as I'm concerned.
Yeah.
There are going to be exceptions to that, but I would start from the assumption of, can I take advantage of somebody else's code?
Yeah, that makes sense. Yeah. On that same line, someone mentioned this particular project. I guess it's pronounced Odoo, ODOO. It's a suite of web-based open source business apps. And it's a weird thing to just throw at somebody to say, the person didn't really mention any real specifics outside of like kind of code and some of the tools that they're using. Didn't really mention what the project does so much. Like it's a web backend on top of a large database. So, but I wonder about those kinds of tools, those like large open source business apps. Have you ever explored anything like that? And I wondered, like, has something like that ever come up? I'll mention my own example with it. Like there's a project called Moodle. I don't know if you ever heard of that.
No, I haven't.
So Moodle is a open source learning platform. It's called an LMS, learning management system, if you will. A lot of smaller universities and schools and so forth. And, again, I worked at this school for recording engineers, and that was a project that we decided to take on and use. In that case, it was like a lot of the code was complete for you. You were kind of not doing so much coding, but more like working within the framework to kind of, build it out for your particular project. Have you ever invested in something like that or took time to look at those kinds of projects?
I used to have to play with some of the Zope stuff, which is kind of next to that. The challenge in these situations is always how, to go back to my peg example, how square is your peg, how square is your peg and how round is the hole.
Right.
So there are cases where this fits very nicely and it can save you an awful lot of time and energy. And there are cases where people end up bending over backwards because it's what they know, or,
Right.
Where it can get interesting is, toolkits like this might get you 80% of the way there, but that 20% that you're trying to build may not fit into their model.
Right.
And so the cost of doing that versus the cost of, when you're trying to make architectural decisions about these kinds of tools, you want to have a decent idea what your big picture is so that you can see whether or not where you're going, whether these kinds of tools will actually help you get there. And some of it depends on, how pluggable they are.
Yeah.
And this is back to, things like the argument of, Flask versus Django, right? Like it's
framework stuff. Yeah.
It's framework stuff. And, if you're going to be using an ORM and, having Django's ORM is a huge advantage, but it's an ORM and there's things that aren't so easy with it. And yes, I can download the plugin that causes it to talk to a NoSQL database, but now I've got an octagonal shaped peg and a pentagonal shaped hole, and it might work, and it might not.
Bandsaw.
Right? So it's always the challenge. And kind of similar to that, when in the article he's asking questions about things like SciPy, ML, DL, that kind of stuff. The other challenge with this is the idea of data as code.
Yeah.
And particularly when you're dealing with things like testing, right? Like you've got to be able to manage your data. I see it all the time in my clients. It's like, oh, okay, so how do you test this? Oh, well, we download the latest version of the production database and then we anonymize it and then we run it through. And I'm like, okay, well, I had one client when they were testing, every single time they tested, their BAs would have to go through and find an order that was in the same state as in the production database as what they were testing.
Yeah.
And like, it's just insane. And some of these things that are like order processing that take a lot of steps to build. So we started getting them to build tools. We're like, okay, you could push a button and create a package that was in state number 4 so that they could start testing from that point. And so that kind of thing, being able to manage your test data as if it's code and being able to have your system in different states so that you can test it properly is really, really important. And it's particularly with large code bases, it just becomes another challenge on top of everything.
Yeah, that makes sense. Like, I think about the times I was working with these real estate, mortgage kind of databases, and it's like very, very specific things that, like, okay, well, this one has to hit all these guidelines, and this one needs to hit these ones. And what if there were 4, borrowers on this thing? And it's like, kind of these crazy edge cases that,
yeah, and you might
it's better you make them in advance.
Yeah, and you might get in a situation where the current state of your test database doesn't have that situation in it. And then how do you test it, right? So,
right. Yeah. Well, I think that takes us into projects. Did you want to go first on that, or do you want me to go first?
That's fine. Yeah.
Okay.
So my project this week is a tool by Hakan Selik called Unimport. And it's a linter that specializes in dealing with unused imports. And like everything, you pip install it, and kind of like Black, you point it at a directory and just say go. And it goes through your target Python files and removes any unused imports that it finds. It gives you notifications, and it's all pretty and colorized to tell you what files that it touched. And from what I can tell, it seems to fairly robustly handle a lot of the weird little corner cases that can happen. So there are situations with typing where you end up expressing the type in a string. So the language doesn't necessarily see that an import's being used. Similar with like using Dunderall, it understands all this. They've figured out how to check for all these things. It's got pragmas for skipping things. They've got their own built one called Unimport, and then they use the no QA one, which is fairly common in other tools as well. Documentation is actually quite comprehensive. He includes things on like how to use it in a pre-commit hook, how to use it in Docker, how to use it in GitHub Actions. So he's covered a lot of the major pieces. Personally, I've always ever done this with PyFlakes, and it's a manual process. PyFlakes says it's unused, and then I go and fix it manually. But this is my favorite kind of tool, the kind that just sort of does that one thing, does it well, and goes off and does it for you. As an aside, Hakan also wrote something called unexport, which helps you keep your Dunder all values up to date. So if you're using that feature in the language, that might be worth checking out as well.
Nice. I have a quick update on 2 weeks ago. I mentioned the rsync-time-machine. Bozen, he actually listened to the show, or the fact that you linked him in our release of it, and he noted the stuff I had done, talked about like excluding certain directories, and that you had to kind of do a little research to learn how to set that up. He's updated our sync time machine to deal with that, and it has it in the documentation now. So
look at you,
nice
wielding
quick
power.
I got like listed, like I had done an actual pull request, and it was like, well, I didn't do that, but it's nice that you mentioned it, and then sent me an email about it, which was really cool. So this is another kind of community thing that kind of hopped into our transom here, like, or under the transom, or however you say that. He has it listed as a small iOS app for iPhone that allows you to link to, basically add links that you've heard in podcasts, such as ours. I think Talk Python and Python Bytes is also mentioned in there. And it will add those links into your Reminders app inside the iPhone. And the fact that he says that it's an iOS app is a little misleading in there, but it's a project by Daniel Engvall, and it's on GitHub. And again, I think I already said the name, but it's called memocast. If you were listening to this show right now and you wanted to select one of the links that we just mentioned, such as this one, and have it like appear in your Reminders so you can, go and look at that later, this is a tool that's kind of doing it. And what he's using to kind of leverage this whole deal is a iOS app that's called Pythonista, which it allows you to run scripts, but you can also create actual other larger applications right on your phone. I'll talk a little more about Pythonista in a second, because it's been around a few years and it's actually a pretty powerful tool. His project does a lot of really nice stuff of showing you, if you wanted to learn how to do some of this stuff, a lot of the features and how you can kind of implement that with your phone. It shows you how to create what's called a share extension that would then run the Pythonista script, and how to then it could connect to the reminders app inside there. He's using a very specific podcast player, in this case, Google Podcasts, so it's kind of wired for that. I personally use a different podcast player, but I downloaded it, tried it all out, and it totally worked fine. It was really cool. He also shows you how, with a separate script, how you can install a different script through a URL. And I think that's kind of a neat thing to kind of check out. So lots of good stuff like demonstrated within this project of how to, if you're interested in having your phone do a little, fancier kind of thing, and your go-to tool usually is Python as far as like how you think and organize code, then I think this might be a neat way to kind of get into that stuff. Pythonista has been around several years. It's always been kind of like under the Apple radar as far as like allowing things that you could do system-wise within your phone. And everybody's always thought that it would get kicked off the platform, but it's still here. It's by Ole Zorn, OMZ Software is the name of it, what he publishes stuff under. And it's a $10 one-time fee thing. And I think I'm on version 3. Currently, the scripting environment is in Python 3.10. You can use iPhone, iPad, other iOS devices, and it is very much a batteries included kind of thing. It has popular third-party modules like Request, NumPy, Matplotlib, Pandas, and lots of that stuff tailor-made, ready to go for iOS. You can access your sensor, location data, photo library, contacts, reminders, clipboard, all that kind of stuff. So it kind of lets you harness a lot of Python stuff within iOS, which is pretty neat. I've played around with it a little bit. It's mostly like a learning tool. It has a REPL. It has a full featured code editor, syntax highlighting, code completion, and so forth. So, and also supports graphics and multi-touch. They actually have some games and stuff that you could create on. So kind of two things in one, Pythonista being the platform that he used to work inside there, and then his project, which was the memocast, which again has support for our show here. And that's actually something I wanted to mention also. If you're not aware, we do have really thorough show notes. I create them every week with links and additional links. They're available at realpython.com/podcasts. If you have a fancier player, such as like Overcast or Google Podcasts or Apple Podcasts, or even Spotify has the links now in there. I also create chapters so you can navigate the episodes. So if you're not using a fancier player, but you can go around and click on the different areas if you want to replay a story or navigate to a different part of an episode you listened to a while ago. And all the links are there for you. That's how he's able to take advantage of this feature. And I don't do this often, but I would like to throw out a request. If you enjoy the show, which is free, can you help us out and leave a review? That would be great. You can do it on Apple Podcasts or whatever platform that you like. It really does help the show to get exposure to other people. So, or, tell somebody else about the show if you like it. Spread the word.
I would just like to rephrase, help us out and leave a positive review, just so we're clear.
Yeah, please. Yeah. Again, if you enjoy the show, which is free, help us out and leave a nice review. Well, thanks again, Christopher, for bringing all these projects and topics this week.
Always a pleasure.
All right. Talk to you soon.
Bye.
I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Paley, and look forward to talking to you soon.